My dear friends, let me discuss the concept of oscillations, in which we have to prove that a body which is going in an anticlockwise direction in a circular motion is going to represent simple harmonic motion. And how is it going to be possible? Let us see here now. Let us consider the particle is moving in an anticlockwise direction with a constant velocity. Velocity is going to be constant here. Okay. So if velocity is going to be constant, let us drop one perpendicular along the x dash and another perpendicular here and here, which along the yo and y dash, two x-axis and y-axis. Now, in this case, if you take this angle as theta, which can also be taken as omega t, because angular velocity is nothing but angular displacement by time, and angular displacement is nothing but angular velocity into time here. So therefore, if this is sine omega t, now let us take the distance from here to here as x and this distance as going to be y here. So in such situations, if this is y, this is also going to be y here. Now let me write here cos omega t, which is taken as this angle and adjacent side is x, and this is going to be radius and also called as amplitude. Why is it amplitude here? This is going to be a mean position and this is going to be an extreme position. So from mean position to extreme position, if displacement slowly increases, it is going to become an amplitude. So therefore, this can be taken as radius and it is also going to be an amplitude here. So therefore, cos omega t is nothing but adjacent side by hypotenuse. So here, x can be taken as r and also taken as r is can also be taken as a here. So a. So it can also be taken as a cos omega t. Similarly, if you take sine omega t. So this sine omega t can be taken as opposite side, that is y, and hypotenuse is taken as an amplitude, that is a here. So I can write this as y is equal to a sine omega t. Okay. So if this is y is equal to a sine omega t, we can find out velocity also, because we got displacement along the x-axis and along the y-axis. Then here, so displacement along the y-axis, if you consider, we can find out the velocity by just differentiating this concept here. No, we are going to differentiate the above one, getting velocity here, that is dy by dt. If you differentiate this one, amplitude is going to be constant, and sine omega t can be taken as cos omega t after differentiation, and this omega t, if you differentiate, you are getting omega here. That's why you write, and dt by dt gets cancelled here. So double time you have to differentiate. We're getting velocity now. So therefore, we got velocity as a omega cos omega t. Okay. How can we find out an acceleration? If you differentiate velocity once again with respect to time, you are getting acceleration here. So acceleration is nothing but dv by dt. That means you have to differentiate all this. So here, this can also be taken as a omega. If you differentiate cos omega t, you will be getting minus sine omega t. And again, if you differentiate omega t, you will be getting omega once again, and dt by dt gets cancelled. So one more omega if you add here, if you multiply here, getting omega square here. Okay. So therefore, acceleration is equal to minus, so omega square, and here a sine omega t is taken as y. So here also a sine omega t can be taken as y, which is nothing but omega square into y. So we got velocity, we got acceleration, we got velocity here. How much is going to be the velocity? Velocity is a omega cos omega t. Okay. If you want, you can take capital A omega cos omega t. So what is going to be the maximum velocity? Velocity is going to be maximum at the mean position, and at extreme position it goes to stop, another extreme position it is going to stop. So velocity is going to be maximum at the mean position. Therefore, at the maximum velocity, the maximum value of cos omega t is 1. Angle for trigonometric functions like cos omega t lies between -1 and +1. So maximum value of cos omega t is going to be 1. Therefore, V maximum is going to be omega A. Then if you get an acceleration as minus omega square y, then what is maximum acceleration? Maximum acceleration can be taken as minus omega square A. Here, y is going to become A, because acceleration is maximum at the extreme positions and minimum at the mean position. Okay, so acceleration is always directed towards the mean position. Therefore, we're getting acceleration as maximum, which is minus omega square into A. That's it. Welcome to Fakhruddin Academy. My dear students, today I'm going to give you a simple explanation for time period of oscillation of a simple pendulum here. Let me discuss. Whenever you take a simple pendulum, this is said to be the mean position. And when you take the simple pendulum to other side, making certain angle theta, there is one more force acting on that, which is called as restoring force, which will again bring back the pendulum to the mean position from the extreme position. This is said to be the extreme position where it goes and stops and comes back again. So therefore, if you consider this as a curve and that distance is taken as x here, which is said to be the length of a pendulum is taken as L here, then you are going to do one thing here. How many forces are acting on that pendulum? One is mg is acting downwards in this direction. Exactly, these two angles are going to be same because they are said to be corresponding angles. These two lines are parallel, so these two angles are said to be corresponding angles. Therefore, this is mg. This is going to be mg cos theta, and this force which is said to be mg sin theta, and this force is said to be mg sin theta, which is called as a restoring force. Why is said to be restoring force? And that too it is negative here because this is the force which brings back the pendulum from extreme position to mean position, which is going from mean to extreme. So this is a reverse force acting. That's the reason why it is going to be negative here. Therefore, restoring force is taken as ma, which is equal to minus mg sin theta. Mm gets cancelled. A is equal to minus g sin theta. If this angle is very small, that it is less than 5 degrees, then we can write sin theta is equal to opposite side by hypotenuse. Therefore, acceleration is equal to minus g. Sin theta is opposite side is x by L. So x you write here, by L you write here. This can be considered as equation number 1. You know the general equation. Acceleration is equal to minus omega square into x. This is taken as equation number 2. Compare these two equations and write a simple formula, that is omega square is going to be g by L and omega is going to be root of g by L, and you know omega is nothing but 2 pi by capital T, which is nothing but root of g by L. You make it reciprocal. You make the reciprocal and do the cross product. Then we're getting T is equal to 2 pi root of L by G, and this is going to be the time period of a simple pendulum. Simple formula. That's it. My dear students, today I am going to discuss about what is the time period of a loaded spring which is oscillating up and down. When you pluck this loaded spring, mass m is plucked downwards, it's oscillate up and down, and the displacement from mean position to extreme position is given as x here. Then what is going to be the time period of this loaded spring? For that, you always know that force is always directly proportional to displacement but opposite in direction. Okay, and that's the reason why we write this as minus kx. We write force as minus kx, and that force is called as restoring force. Whenever you pull the body downwards, one force will again take the body to the mean position, and that is said to be restoring force, which is given as minus kx. And you also know force is equal to mass into acceleration. This is a general formula. Make them equal, then you will get ma is equal to minus kx. A is equal to minus k by m into x here. Okay, but you all know what is the general formula for acceleration. Acceleration is given as minus omega square into x. Make them equal again, then what are you going to get? Omega square is equal to k by m. Therefore, this implies that omega is equal to root of k by m. You know omega is nothing but 2 pi by capital T, which is nothing but root of k by m. So you make it reciprocal and do the cross product, you'll be getting T is equal to 2 pi root of m by k. That's it. Going to be the time period of simple pendulum oscillation. That's it. My dear students, today I am going to discuss about oscillations chapter, in which a small concept is there which is called as velocity displacement graph. Velocity is along the y-axis and displacement along the x-axis. Let me discuss about this graph. You are very much familiar. You are very much familiar by this equation, that is v is equal to omega square root of a square minus x square. This is a very familiar equation which you know about that. Now, squaring on both sides, you just write v square and this omega square, let me write in the denominator, that is omega square, and right side only a square minus x square is left because square and square root get cancelled here now. Then v square by omega square, this x square you can just take to left side. Then what is left at the right side? Only a square is left. Okay. So finally, you are writing v square omega square. This a square comes to denominator, becomes a square plus x square by a square is equal to 1 here. Okay. So this is the final equation you're getting. So from this, it is understood that displacement velocity is showing an ellipse here. Okay, where along the y-axis omega a is present, along the x-axis amplitude is present. So this is going to show the ellipse equation. That's it. Thank you very much. My dear students, today I am going to explain about the graph which explains acceleration velocity graph, and we have to prove that it is having a shape of an ellipse here. Before that, you should know the basic formula that acceleration is equal to omega square x, and you should also know that velocity is going to be omega square root of a square minus x square. And if you square this on both sides, it is going to be v square is equal to omega square a square minus x square. Okay, and here in the place of x, you have to substitute x is equal to a by omega square. This value, if you substitute here, we're getting v square is equal to omega square a square minus x square, where x square is equal to a square by omega power 4, because you have to square this one. Then after that, v square is equal to omega square a square minus omega square 4 gets cancelled here. What is left now? A square by omega power square. That's it. So this is going to be left here now. Then you just shift this one to left side. V square plus a square by omega square is equal to omega square a square is left here, which is left here. This comes to left side. Then finally, what is going to get now? The simple thing is v square you write like that only, and this you shift to downwards, which is going to be omega square a square plus a square divided by shift to this denominator. There's going to be omega power 4 a square, which is equal to 1 here now. The simple thing is, the final step you are going to write like this: v square divided by omega a whole square plus a square divided by omega square a whole square. Okay, it's going to be capital A, which is equal to 1. That's it. So this is in the form of an ellipse. This is said to be the equation of an ellipse. Therefore, velocity acceleration graph is going to be having a shape of an ellipse. That's it.